Hello everybody, we are discussing today the physical optics from physics. I am Srinivasa Charyulu dealing the topic. Physical optics in fact deals with the wave nature of light. What are all the concepts and phenomena related to waves? That means light behaving like waves when we consider the nature of its behavior and the concepts of interference, diffraction and polarization. These are the three major concepts we are going to discuss in this particular chapter. Physical optics, when we talk about, the very first concept is interference. In fact, interference, diffraction and polarization, all the three different kinds of phenomena were showed by both longitudinal and transverse waves. Interference and diffraction only can be given both by longitudinal and transverse waves, whereas polarization is going to be exhibited by only transverse waves. That means polarization, when we talk about, theoretically speaking, transverse waves only can be polarized but not the longitudinal waves as such. That means we can understand light waves can be polarized, whereas sound waves cannot be polarized. That is the point. So let us take up the formula related to interference first of all. If you just take up interference part, what exactly are the concepts? Suppose y1 is equal to a1 sin omega t, that is one particular waveform, and y2 is equal to a2 sin omega t plus phi. In fact, these two waves are interfering and forming an effective wave or the resultant wave. What would be the displacement of that resultant wave? We can understand that is the sum of these two individual displacements. So y is equal to y1 plus y2. Now in this particular case, what is the formula to be remembered? Intensity is equal to 4a square cos square phi by 2. This is the formula. But in fact, we people all can understand this a square can be written as the actual intensity, that is 4I naught cos square phi by 2. This is the formula. So this equation is the first equation which one should remember. And coming to the next one, when you are talking about A1 and A2 are the amplitudes, omega t is going to be the phase here, phase difference between them is phi. For observing interference pattern, the minimum necessity over here is that we need to have two coherent sources. What are the conditions for the sources to be coherent? Coherent sources are those sources which can provide light of same amplitude, same wavelength, either with the same phase or with constant phase difference. Even amplitudes are different also, okay. But either phase must be equal or phase difference should be constant. Either of the conditions that should be valid. If at all the conditions are valid that way, we can say that pair of sources as coherent sources. But one need to understand a theoretical concept here. Two separate sources can never be coherent. That means two individual torchlights or two different bulbs or any two separate objects which can give out light, they should not be considered as coherent and they cannot be coherent also. Remember that point. Another theoretical concept here is coherent sources may be both real or one real and one virtual or both virtual. This also is one of the concepts one has to remember. In addition to this, if I consider A1 and A2 are their actual amplitudes, what will be the maximum amplitude of the resultant wave which has been formed due to interference? A maximum we can write A1 plus A2. Similarly, A minimum we can write A1 minus A2. So the difference gives you the minimum amplitude, the sum gives you the maximum amplitude. In addition to that, we know intensity is proportional to square of the amplitude. Therefore, we can now write I maximum by I minimum is equal to A1 plus A2 whole square divided by A1 minus A2 whole square. By any chance sustained interference is taking place, perfectly interference pattern is obtained, then we can understand that if at all A1 is equal to A2, then you can understand well I maximum is going to be 4A square and I minimum is going to be simply 0. That means at dark band you cannot find brightness at all. No light wave that is going to reach that particular point. Therefore, in any interference pattern, alternate bright and dark bands are going to be observed. Another point you have to remember here is interference is just because of the overlapping of waves, no doubt. And here what is conserved? Energy is going to be conserved. So interference pattern is going to be formed in accordance with the law of conservation of energy. Only redistribution of energy is making us obtain bright and dark bands of interference. That is the concept you have to take. Coming to the next concept over here, what are the conditions for obtaining bright band? You can definitely understand here, for obtaining a bright band, okay, that is also called bright fringe. That is interference fringes we used to call them. So bright fringe, for obtaining that, what is the first condition? Path difference must be equal to n lambda, where n is going to be 1, 2, 3, 4, 5 and so on and an integer. Likewise, the phase difference over here corresponding to this one is going to be n into 2 pi. That means what is the relation over here? You can certainly understand. Phase difference phi is equal to 2 pi by lambda into path difference. This was the relation what we have taken in simple harmonic motion as well as in wave motion. So according to the same concept, lambda path difference means 2 pi will be the corresponding phase difference. That's lambda path difference is 2 pi phase difference. That is the concept. Likewise, for obtaining a dark band, that is, of course, we can call it once again as a dark fringe. Then what is the condition? Path difference in the case of obtaining a dark fringe must be 2n minus 1 into lambda by 2. And what is going to be the corresponding phase difference over here? 2n minus 1 into pi. 2 pi means lambda, pi means lambda by 2. So these are the conditions for obtaining dark band and these are the conditions for obtaining a bright band. Now come to the next case, please. Suppose if that fellow says there are two waves which are just giving us interference. Y1 is equal to A1 sin omega t and Y2 is equal to A2 sin omega t plus phi. Plus or minus, of course, we can take up. An example I am just taking up. So if you consider what will be the resultant amplitude, they may ask you just giving two equations like this waveforms. Then it is root of A1 square plus A2 square plus 2A1 A2 cos phi. This is the formula. By any chance, if you consider A1 and A2 are equal, then A resultant will now be equal to 2A cos square phi by 2. That is the point. You can directly understand this one. So this is the resultant amplitude equation that of course you can even write in terms of intensities also. So this is one more equation you have to remember. And coming to the next one, whenever the widths of the two slits are given, then we should understand intensity is proportional to width of the slit. So how to rewrite this equation now? I1 by I2 is equal to W1 by W2. You can even rewrite the same this way also. A1 square by A2 square. This is the ultimate result you have to remember, where W1 and W2 are the corresponding widths of those two slits which are producing interference pattern over there. So that is one more condition. Now come to the last one. Suppose if one of the slits, if you people are taking up, the one of the slits over there is covered by a small film of thickness, say T. Then what is the fringe shift that is produced? The fringes are going to be shifted in that particular case. Fringe shift we used to represent it by X. That is nothing other than d by d into mu minus 1 into T. This capital D is the distance to the screen. Small d is going to be the distance of separation between the coherent sources. Mu is the corresponding refractive index of that medium which is obstructing the path of light, and this t is going to be the thickness. Now the same even you can write this one as beta by lambda into mu minus 1 into t as well. What is this beta here? Beta is called the fringe width. Fringe width. Width means, of course, we can understand the thickness. That's beta is equal to lambda d by d formula. So automatically d by d can be written as beta by lambda. So this is the formula that is to be taken up when fringe width is to be calculated in this particular concept of interference. Now if you take this particular equation beta, distance between two successive bright fringes and distance between two successive dark fringes, anything of course, we represent that one by fringe width, that is beta. So beta is going to be constant whenever we get sustained interference, a perfect interference phenomena or pattern. When that is obtained, then automatically beta for a bright fringe as well as a dark, it's going to be one and the same. So these areas we have to look into. As far as diffraction is concerned, there are simply two different types: Fresnel diffraction and Fraunhofer diffraction. If you consider Fresnel diffraction, this is finite diffraction we call it, and this one is infinite diffraction we used to call it. And Fresnel diffraction, of course, Fresnel's explanation has been given by considering half period zones. These half period zones, whatever they are reaching the particular point on the screen, if even numbered zones are reaching there, the brightness decreases on the screen at that point. If odd numbered zones are reaching there, brightness increases. And this diffraction is nothing other than encroachment of the dark space, the dark part of that particular shadow. This is just because of bending around the corners by waves. So these areas we have to concentrate on. Coming to the next one, that is regarding polarization. I have already told you only transverse waves can be polarized, but not the longitudinal waves as such. One area is that. And coming to the second one, whenever the polarizing angle we consider, that means what? Whenever a ray of light is just striking here, this is what we call it as unpolarized light. This unpolarized light will be consisting of what? Arrow component will be there and dot component also will be there. Dot component means perpendicular component, arrow component means along the same space or the particular rather xy plane. That is the point. Now this is unpolarized light. When reflection takes place and refraction takes place here, if reflected light is totally polarized, polarized in which particular direction? A particular plane. Therefore, that's called plane polarized light. Whenever this reflected light is polarized completely, then whatever the angle of incidence that is observed is called polarizing angle. At this particular juncture, you should understand that reflected and refracted rays are mutually perpendicular to each other. That is the second point. And third aspect is mu is going to be tan of IP. What is this mu now to be called? Refractive index of the denser medium with respect to the rarer medium, that is of this glass in this particular example, is equal to tan of polarizing angle. If at all you want to equate that one to critical angle, you should write that is equivalent to sin C. That is actually the concept what we have to take up. So this is actually from this particular chapter, that is called Brewster's law. So this is one area. And by reflection we can polarize light. By refraction we can polarize light. By using double refraction concept we can polarize light. Exactly in the same manner, by using Polaroids also we can polarize the light. While using Polaroids, what is the general concept here? The intensity of light that is coming out of the Polaroid is equal to I0 by 2 cos square theta. This is the formula. That means while passing through the first Polaroid, 50% of light only will be emergent out. That means what? I naught, if it is the initial intensity, I naught by 2 only will come out. And what is this theta? That is the angle between the Polaroids, whatever are being used over there. So these are the theoretical implications or the formulae one should remember before going into the applications part of this particular chapter as such. So let us now take up some of the problems over here based on all these concepts whatever we have discussed. Look at the very first problem first. That is based on interference as such. Two light waves are represented by y1 is equal to 8 sin omega t and y2 is equal to 6 sin omega t plus pi by 2. The resultant amplitude due to interference will be how much? That is the concept. In fact, we know y1 is equal to 8 sin omega t and y2 is given 6 sin omega t plus pi by 2. You can understand pi by 2 is going to be the phase difference between these two. Then what will be the resultant amplitude over here? I said root of 8 square plus 6 square plus 2 into 8 into 6 into cos pi by 2. You all in fact know well cos pi by 2, cos 90 0. So this gets cancelled. So how much it is left now? Root 100. So it will now be 10. 10 what? If all these values are given in centimeter, this also will be in centimeter. If that is given in meter, this also will be in meter. In this particular case, since we people are taking them in centimeter, the value of resultant amplitude will now be 10 centimeter, which is the very first option that's going to be correct here. Look at the second problem now. That problem also is based on interference only. Two coherent sources of different intensities send waves that interfere. The ratio of maximum to minimum intensities is 25. The intensity ratio of the two sources is how much? Maximum to minimum intensities, that is the value given as 25. So you can understand this way, I maximum by I minimum, which of course we all know A1 plus A2 whole square divided by A1 minus A2 whole square. That's value is given 25. 25 means what after all? 25 by 1. That is the understanding. Now you can write directly A1 plus A2 by A1 minus A2, which now is root of that. So it is 5 by 1. So can't I simply apply componendo dividendo to write A1 by A2 is equal to 5 plus 1 by 5 minus 1 please. So this is 6 by 4, which now is 3 by 2. But in fact, these are the amplitudes of the initial waves which are overlapping or interfering to produce perfect interference pattern with this maximum intensity and this minimum intensity. So what is his question there? What is the ratio of the intensities of both the sources? That means what is I1 by I2 individually? A1 square by A2 square. So how much it will now be? 3 square by 2 square, which now will be 9:4. So 9:4 is going to be the ratio of their intensities. So which option is correct there? The third option is correct for this second problem. So this is the concept, this is the method of doing this model. Several times this model has been asked at Eamcet examination, please. So concentrate on this one thoroughly. Look at the next number. Two coherent point sources S1 and S2 vibrating in phase emit light of wavelength lambda. The separation between them is 2 lambda as shown. The first bright fringe is formed at P due to interference on the screen placed at a distance capital D from S1. Then OP is how much? That is the concept. This particular question has been asked in last year's Eamcet paper only. So one should understand what is the figure they have given us first of all. Look at this. This is the figure what they have given. They said there is a point here as P. There is a particular source over here. There is another source over here. What are the two sources? Yes, mentioned over here. You see, S1 is this source, S2 is this source, and this distance is given 2 lambda. That's what has been given. Now come to this one. This point, this is connected to this point. This is also connected to this point. That means if you just draw one perpendicular, won't this now be the path difference, please? And he has given you this angle as theta. In addition to that, what is the other distance he has given? This length he has given it as x. and secondly this is given as O. And what is this total distance he has given between the screen and the first slit over here? That is given capital D. That is actually the concept there. Now this is the description. What he just wants us to calculate is what is OP. That means what is X is the question. So first of all, if you just look at this figure carefully, S1P minus S2P, is it not called path difference, please? So I now can write directly this way. Path difference is equal to nothing other than this adjacent side. So how do we get path difference in the case if it is a bright band like it is n lambda? But suppose if n is equal to 1, then what can I write? Then you can understand directly that path difference is equal to lambda. Remember this as the first result from the figure. And what is the second one? Just to check this particular point, please. This I take it as Q. From this, what is cos theta you identify? What is cos theta? Adjacent side, that is nothing other than path difference. Divided by, what is this hypotenuse over here? It is given 2 lambda. But already we people know cos theta is equal to path difference by 2 lambda. This is one area. Again, from this particular triangle, when I take this distance as D and this distance as X, then what will be this particular distance, please? Is it not root of D square plus X square, please? Now once again you write what is the formula for cos theta from this particular triangle. Which triangle I am considering? S1OP. That is actually the case. Triangle S1OP. Then what is cos theta? It is adjacent side by hypotenuse. That is capital D by hypotenuse is going to be root of D square plus X square as such. This is the point. But why can't we directly equate these two now? Because this is cos theta, this also is cos theta. Come on, equate these two. What is path difference? Already we have got lambda. So lambda by 2 lambda is equal to D by root of D square plus X square. Now lambda getting cancelled. Come on, square it up please. 1 by 4, that is you cross multiply it first. 4D square is equal to D square plus X square. In other words, X square will now be equal to 3D square, please. Then what is X the question? Is it not root 3 times D, please? That is actually the formula. That is in fact the answer for this particular concept. So what is correct option over there, please? Third option, which has been given as root 3 times D, that is going to be the correct option for this question number 3 as such. One of the excellent ways that fellow has framed this question, please. Last year's Eamcet question it is. Now check the next problem. That problem number 4. In Young's double slit experiment, the resultant intensity at a point on the screen is 75% of the maximum intensity of the bright fringe. Then the phase difference between the two interfering waves at that point is how much? That is the concept. So it is 75% of what? 75% of the total or maximum intensity. That is the concept here he is talking about. So generally, if I take intensity 1 as 4A square directly, let us say. Now intensity 2 now becomes 75% of 4A square. That means how much it will be? 3 times 25 and 4 times here. This gets cancelled. So what will now be this value of I? 3A square. So I is equal to I naught cos square 5 by 2. That is actually the formula what we people used to take up. Now 4I naught, that is the maximum value 4A square. Now what is I over here? 3I naught is equal to 4I naught cos square 5 by 2. Now I naught getting cancelled. What will be cos theta now you look at? Is it not simply root 3 by 2 please? Cos 5 by 2 you take root 3 by 2. What is this cos 5 by 2 root 3 by 2 means? 5 by 2 is equivalent to 30 degrees. Then what will be the value of phi? That will now be 60 degrees. 60 degrees means how to rewrite that one? Pi by 3 must now be the correct option. Look at that one. The option must be the third one over here, which is 60 degrees means pi by 3. That now must be the correct option for this. One of the excellent models, 75% of what is very important. Not of individual intensity. He is talking talking about 75% of the maximum intensity. That is the clue for this particular problem as such. Look at the next problem, that is problem number 5. In Young's double slit experiment, the intensities at 2 points P1 and P2 on the screen are I1 and I2 respectively. If P1 is located at the center of a bright fringe and P2 is located at a distance equal to a quarter of fringe width from P1, then I1 by I2 is going to be how much? Now, initial one you can take it as 4a square, there is no doubt about that, fine. What about I2? Quarter of that, that means 4a square cos square pi by 4. Pi by 4 of course is cos 45, it's 1 by root 2. 1 by root 2 whole square will now be 1 by 2. So 4a square by 2, this now becomes 2a square. Then what will be the value of I1 by I2? The question. 4a square by 2a square, which now should be 2. That means what? 2:1 must be the ratio. So, which option is correct over there? It should be 2. 2 means 2:1, it is understood. So, very first option is going to be correct for this particular question number 5. Please recollect that one. Let us see the next number. Question number 6. In Young's double slit experiment, the 10th maximum of wavelength lambda 1 is at a distance of y1 from the central maximum. When the wavelength of the source is changed to lambda 2, 5th maximum is at a distance of y2 from its central maximum. The ratio y1 by y2 is how much? y1 is the distance. Distance means simply speaking the path difference over there. So you can certainly understand path difference is equal to, in fact, n lambda. What is the first one here he has given you? 10 lambda 1. And what will be the second one he has given you? 5 lambda 2. That is the case. This is the path difference in the first case. This is the path difference in the second case. What is his question? What is y1 by y2? Very simple. 10 lambda 1 by 5 lambda 2. This goes twice over here. So 2 lambda 1 by lambda 2 must now be the corresponding option for that. See that first option carefully please. 2 lambda 1 by lambda 2. That itself we people have got here. That only has been given as the first option for this problem number 6. Let us check the next number, that is problem 7. 4 sources of light produce the following 4 waves. Look to those 4 equations carefully. y1 is equal to a sin omega t plus phi 1. y2 is equal to a sin 2 omega t. y3 is equal to a dash or a1 sin omega t plus phi 2. y4 is equal to a1 sin 3 omega t plus phi. Superposition of which 2 waves give rise to interference? Very simply, if you observe carefully these 4 equations please. First one and third one, when you look at, even though amplitudes are different, the first one has got a phase of phi 1, phase difference. Second one has got a phase difference of phi 2. If these two interfere, what will be the effective phase difference over there? Either phi 1 minus phi 2 or phi 2 minus phi 1, which is definitely going to be constant phase difference. So for obtaining interference, the minimum condition is, I said already, either the phase must be same for both of them or phase difference should be maintained constant throughout. Then only we will be getting perfect interference pattern, otherwise not. So out of all the 4 equations of waves what have been given, first one and third one put together, they can have constant phase difference concept. Therefore, there is a possibility for them to produce interference pattern as such. So, third option is the correct option for this question number 7 please. Look at that next problem, that is 8. Young's double slit experiment. First slit has width 4 times the width of the second slit. The ratio of the maximum intensity to minimum intensity in the interference fringe system is how much? Widths already we have discussed. Intensity is proportional to the width. That is the concept. So what has been given here? Width of the first one is 4 times the width of the second. That is what has been given. In fact, I can write this way. I1 by I2 is equal to W1 by W2. So W1 can be taken for W2 now. By W2 as it is W2 getting cancelled, you are left with 4. What is this 4 equals to? A1 square by A2 square is equal to 4. Then what to write? A1 by A2 will now be simply 2. Then what is his question there? His question is maximum intensity to minimum intensity. Then what is the general formula for this one, please? A1 plus A2 whole square divided by A1 minus A2 whole square. This is the formula. A1 and A2. One is 2 and one is 1. 2 plus 1 whole square, it is 3 square. By 2 minus 1 whole square, it's 1 square. So what should be the ratio now? 9:1. That must be the ratio of maximum intensity to minimum intensity. So remember this formula thoroughly so that you can directly work out such model questions easily. So what is the correct option for this problem now? It is the third option which has been given 9:1. Therefore, correct answer for this problem 8 is exactly the third one. Look at the next problem. Problem number 9. If in Young's double slit experiment, an interference pattern is obtained on a screen by light of wavelength 6000 angstroms coming from two coherent sources S1 and S2. At a certain point P on the screen, third dark fringe is formed. Then the path difference in microns will be how much? Third dark fringe is formed. That is the concept. Then of course, what is the concept we have to take up? Path difference. In general, we all know that one very well. Path difference is equal to 2n minus 1 into lambda by 2. That is actual formula. N in this particular case is 3. So 2 into 3, 6 minus 1, 5 by 2 into, what is lambda that has been given here? Look at 6000 angstroms. So into 10 power minus 10. You can cut these 3 zeros first over here 7 times. This of course goes thrice. So it is 15 into 10 power minus 7. Can't you rewrite that one? 1.5 into 10 power minus 6 please. 10 power minus 6 meter is called micron. Therefore, 1.5 micron, you can write this one. So, what should be your option now? 1.5 microns must be the correct option for you. That is the second option is correct for this problem number 9. So, just look at this equation carefully. 2n minus 1 into lambda by 2. Right? Let us check the next problem, problem number 10. In Young's double slit experiment, 12 fringes are observed to be formed in a certain region of the screen when light of wavelength 600 nanometer is used. When light of wavelength 400 nanometer is used, the number of fringes observed in the same region of the screen will be how much? That is the concept. So if you look at this one, a very simple question. Question is looking lengthy, but the option is going to be very easily calculated. What is the concept here? N1 lambda 1 must be equal to N2 lambda 2. Where N1 and N2, they refer to the number of fringes which are being obtained. So initially 12 fringes, when this is 600 nanometer, that has been given. Now what is N2 the question? What is the corresponding wavelength given this time? 400 nanometer. Now 2 times 200 here, 3 times 200 here. This 2 of course cancels here 6 times. Then what will be the value of N2? 6 3 is 18. So how many fringes are going to be formed is the question. So 18 fringes are going to be formed when the wavelength has been reduced to 400 nanometer. Check those options carefully. 18 is given as the second option there. So for this problem number 10, second option 18 is the correct answer for us. Look at the next problem, problem number 11. In Young's double slit experiment, fifth dark fringe is obtained at a point. If a thin transparent film is placed in the path of one of the waves, then the thickness of the film in terms of wavelength lambda and refractive index mu will be how much? That is the concept. Just now we have discussed in the beginning, what is going to be the shift produced in the fringe? Shift, if I take it as x, I have already given you two formulae, d by d into mu minus 1 into x or t, that is thickness. Otherwise, you can even call the same this way, beta by lambda into mu minus 1 into t. So in this particular case, very clearly is mentioning fifth dark fringe is obtained at a point. That is the concept. Now what is the concept here? Fifth dark fringe is obtained. And what is he talking? If a thin transparent film is placed in the path of one of the waves, then the thickness of the film in terms of wavelength lambda is how much? That is the concept. So you can take fifth dark in the sense what is the concept there. It is now to be taken, the shift produced is going to be 3 beta by 2. Fifth dark, suppose if I take directly, you can take 2n minus 1 into lambda by 2. That fifth dark in the sense, what is the thing? That fifth dark is now becoming sixth bright, that is seventh bright. That means what? 3 lambda by 2. That of course we people can say 3 by 2 times beta, that's a better choice, is equal to beta by lambda into mu minus 1 into t. So then automatically beta gets cancelled. T will be 1.5 lambda by mu minus 1. Look at this particular option where it has been given, please. 1.5 lambda by mu minus 1 is the correct option for this particular question number 11. So first option is the right option for us. So that is the concept. Look at the next problem, that is problem number 12. In Young's double slit experiment, fringes are obtained using light of wavelength 4800 angstroms. One slit is covered with a thin glass film of refractive index 1.4 and another slit is covered by a film of same thickness but of refractive index 1.7. By doing so, the central fringe is shifted to fifth bright fringe in the original pattern. The thickness of glass film is how much? That is the concept. If there is only one particular film, this is the formula what we have taken in the previous problem. Now he is using two different films, one against each slit there. So two slits are there, two films are placed. What is common feature of these two films, please? The thickness is common, thickness is same. What is different? Refractive index is different. Therefore shift you can write as x is equal to d by d into mu 1 minus mu 2 into t. Mu 1 minus mu 2 gives you the difference of refractive indices of both the films. The second way of writing the same formula is beta by lambda into mu 1 minus mu 2 into t. But be careful about this shift, please. It has been shifted to what? He has given you very clearly, it has been shifted to the fifth bright fringe. That means this is now to be taken 5 beta is equal to beta by lambda into mu 1 minus mu 2 into t. What is lambda that has been given over there? You check there. It is 4800 angstrom units. That means you can write that into 10 power minus 10 into mu 1 minus mu 2, 1.7 minus 1.4 into t. This in fact beta gets cancelled. This is going to be simply 0.3. We can understand that one well. Now come on, you cross multiply this. T is equal to 5 times 0.3. I write 3 into 10 power minus 1 into 48 into 10 power minus 8. That is actually the concept. So if I take this 3 into 10 power minus 1 now comes down because this is actually multiplying here. So 5 into 48 into 10 power minus 8 by 3 into 10 power minus 1. Now you can cut this one over here minus 7 times, fine. This 3 goes here 16 times. 5 into 16, that's going to be 80 into 10 power minus 7. That is 8 into 10 power minus 6. You will be getting there. So this is actually the point. Look at now 8 into 10 power minus 6 what? Meter. But that fellow is very cleverly, he is giving the answers in millimeter. Then what you should do? You multiply this answer with 10 cube. 10 cube if you multiply with, you get in millimeter. So what will be your answer now? 8 into 10 power minus 3 millimeter. So which option that is correct over there? The fourth option is correct for this question number 12 as such. Only thing is conversion of units that matters, right? That should be taken care of. Look at the next one. Two coherent sources of intensity ratio beta interfere. Then I maximum minus I minimum by I maximum plus I minimum is how much? That is actually the concept. This in fact like a formula one can remember. The concept here is beta is given as intensity ratio. So you can understand beta is I1 by I2. And of course you can even write this one A1 square by A2 square. That is the point. Now what is I maximum over here? Either you can write A1 plus A2 whole square, or you can write root I1 plus root I2 whole square. Likewise, what is I minimum? I minimum is equal to either A1 minus A2 whole square or root I1 minus root I2 whole square. Now according to the given formula, I maximum minus I minimum divided by I maximum plus I minimum. That is what actually he is asking. In terms of what? In terms of beta. If you simplify the whole thing, 2 root beta by beta plus 1 you will be getting. This is simply like a formula. If one can remember, that's a better choice. So this is similar to the second option given in that problem number 13. So be careful about this formula again. Now look at the next problem, that is problem number 14. Light of wavelength lambda is incident on an object of size b. If a screen is at a distance capital D from the object, identify the correct condition for observation of different phenomena. We know very well one A, B, C and D are given there. If B square is equal to D lambda, Fresnel diffraction is observed. That is 100% correct. If B square is greater than D lambda, Fraunhofer diffraction is observed. That is wrong, because B square should be less than D lambda for a Fraunhofer diffraction to be observed. What happens if B square is greater than D lambda? The approximation of geometrical optics is going to be applicable for that. This same question has been repeated at Eamcet examination twice so far. So be careful with these conditions. A is correct, C is correct, and D also is correct. That means A, C and D are true, excepting B, all other 3 are correct. So correct option for this particular problem 14 is the second option here. Remember that. Now come to the next one, that is problem number 15. In Fresnel diffraction, incident wavefront will be. Fresnel diffraction, I have already told you, it is called finite diffraction. Finite diffraction means what? The distance to the source, distance to the screen, both are going to be finite. You will be finding the source there, you will be finding the slit there, you will be finding the screen there. Whatever the image that is formed over there or the diffraction pattern that is formed over there, that will be formed on a nearby screen there. So in such cases, when the source is taken up there at finite distance, either the incident wavefront must be spherical or cylindrical. That means cylindrical wavefront is possible, spherical wavefront also is going to be possible. So see the third option please, either spherical or cylindrical. Same question if suppose they ask you in Fraunhofer diffraction by any chance, then neither spherical will be there nor cylindrical will be there. Whether it is spherical emitted by that source at infinite distance or cylindrical emitted by the source at infinite distance, after traveling through infinite distance, that automatically becomes a plane wavefront. So same question if they ask you for Fraunhofer diffraction, the wavefront will be a planar or plane wavefront as such. So for this question 15, the option is the third option please. Look at that next problem 16. Yet the polarizing angle of refraction will be how much? At the polarizing angle, remember this concept carefully. This is the normal, this is the incident ray. This is what is called polarizing angle. This is reflected ray. This is refracted ray. Now what is the question here? You carefully observe. Angle of refraction, this angle we want. But a bit of carefulness you can understand. Whenever the reflected light is completely plane polarized, then we know pretty well reflected and refracted rays are mutually perpendicular to each other. That is the concept. So you can certainly understand this is IP, this also is going to be IP. So if you just look at this normal carefully, this is IP, this is 90, this is R. Total angle must be 180. Na? So IP plus 90 plus R, That should be 180 degrees. Then what is the concept here? R is how much? 180 minus 90 is 90. So 90 minus IP. That IP is called polarizing angle. In this particular problem, it is given as theta p. Therefore, what should be the angle of refraction over here? 90 minus theta p or phi p, whatever that has been given there, you can write. In fact, this is the formula one should remember for this. So, third option is the correct option for this problem number 16. Look at the next number 17. A ray of light in air is incident on a glass plate at polarizing angle of incidence. It suffers a deviation of 22 degrees on entering glass. The angle of polarization is how much? That is the concept. Angle of deviation is given. Once again, mathematical approach is to be taken care of. Look at this is incident ray. This one is the normal. This is called angle of incidence. That is called also polarizing angle. Had there been no difference between the media, the ray would have gone straight like this without any deviation. But it now reflects a part over here and refracts over here now. This is angle of refraction, we can understand. This angle again is angle of the polarization. This angle is given as 22 degrees. That means had there been no difference between the refractive indices, this ray would have gone straight. Now it is bending this way. This is called angle of deviation. That is now given how much, you see carefully, 22 degrees there. Now check carefully. This angle is going to be IP. This angle is IP. And what is this angle? You know, now look at. This is 90 minus 22. Because total angle is going to be 90, you know. 90 minus 22, how much it is going to be? 68 degrees. Come on, you just look at this straight line. This total angle must be 180. That means 2IP plus 68 must now be 180. Then what will be the value of 2 times polarizing angle? 180 minus 68. 68 means, of course, if I take 70 like 110, 112 degrees you will be getting. So what will be the value of IP? 112 by 2. It is exactly 56 degrees. Look at the option carefully, please. The second option is going to be correct for this question. Same model also has been asked in earlier or previous Eamcet papers. Look at the next problem now. Unpolarized light of intensity I0 is incident on a polarizer, and the emerging light strikes a second polarizing filter with its axis at 45 degrees to that of the first. The intensity of the emerging beam is how much? In fact, I have already told you the formula. Whenever polarides are taken up, I is equal to I0 by 2 cos square theta. That is the formula. Now here what is the angle that has been mentioned? 45 degrees it has been mentioned. So I0 by 2 you write it as it is. This now becomes cos square 45. Cos 45 being 1 by root 2. Whole square when you make it, it becomes 1 by 2. So ultimately I0 by 4 it should become. So the present intensity must be how much now? 1/4 of the maximum or initial intensity. So second option is going to be correct for this problem number 18 as such. Look at the next number. P1, P2 and P3 are 3 polarizers arranged coaxially. The angle between P1 and P2 is 30 degrees. If intensity of emerging light from P3 is 1/4 the intensity of unpolarized light, then the angle between P2 and P3 will be how much? That is the concept. Look at carefully first of all. If I is equal to I0 by 2 cos square theta, when there is a pair of polarides, when there is 2 pairs, of course, when there are 3 polarides in a sequence like, the same formula should be taken like this. I0 by 2 cos square theta 1 into cos square theta 2. What is this I value given? It is 1/4 the intensity of unpolarized light. Unpolarized light is I0 by 4 is equal to I0 by 2 cos square 30, right, into cos square theta 2. That is the formula for us. I0 gets cancelled. 2 cancels here 2 times. So half is equal to, what is cos 30? Root 3 by 2. So 3 by 4 cos square theta 2. That is the formula. This goes twice. So what will be cos square theta 2 now? It will be 2 by 3. Then of course you can write cos theta 2 is equal to root of 2 by 3. Then what will be theta 2? The question. Cos inverse root of 2 by 3. This is the formula. This formula means this like a derivation we have made, but this is ultimate result. So what is the correct option? Cos inverse 2 by 3. That means the very first option is going to be tallying with this calculated value. Therefore, for problem number 19, first option is the correct option. Remember this formula thoroughly for such models. Look at the next number, 20th. The axes of polarizer and analyzer are inclined to each other at 60 degrees. If the amplitude of polarized light emergent through the analyzer is A, the amplitude of unpolarized light incident on the polarizer is how much? Usually intensities will be asked, but he is asking this time in this problem for a change amplitude value. So what is the formula here? I is equal to I naught by 2 cos square phi or cos square theta, whatever you write. But in this particular question, phi is given 60 degrees first of all. So you can write I is equal to I naught by 2 cos square 60. Cos 60 being half, cos square 60 being 1/4. You now can write this one I naught by 8 here, because this is 1 by 4, this is 1 by 2. So 1 by 8, I naught by 8. Okay, but these are intensities. Then how to convert them into amplitudes, please? Intensity is proportional to square of the amplitude. So I can write A square is equal to A naught square by 8. That is actually the way. Now you can directly write this way. A naught square is equal to 8 times A square. What is A naught? A naught is the amplitude of unpolarized light, the initial one. A is the amplitude of the polarized light which is coming out of the analyzer according to the problem given to us. Now we can just take A naught is how much? That is A root of 8A square, which now becomes 2 root 2 times A. Look at the options carefully. The fourth option is going to be 2 root 2 times A over here. So this is the formula by means of which we people can calculate whenever intensity of that light which is coming out of the analyzer in the case of polarization. In fact, we can take one general concept also here. That is, whenever we consider cooling glass specs, like what is the principle of that one? They are all Polaroids. In fact, we know whenever light is entering into the Polaroid, 50% of intensity is going to be reduced as a minimum. 50% is reduced means certainly you can understand even at in the afternoon around 12 o'clock, like when intensity outside is more, when you wear cooling glasses, you will feel as if the total intensity of light has gone down to the extent possible. That of course 50% at least will be having the reduction over there. That is in accordance with this formula only, I will become I naught by 2 in the case of a polarizer. Look at the next number, that is the last problem in this order. That is 21st. A polarizer and analyzer are oriented so that maximum amount of light is transmitted. To what fraction of intensity of light? That is transmitted when the analyzer is rotated through 45 degrees. Firstly, understand one simple concept. Suppose this is a polarizer. The other one I am considering as analyzer. Both in fact have got the cut like this. This is one crystal, this is another crystal. When both the Polaroids are parallel to each other, then whatever light that is incident here, which is unpolarized here, having both dot component and arrow component, only arrow component will come out. That arrow component after incident on this, again arrow component comes out because this axis also is parallel to this. Suppose if I start rotating this one slowly, the intensity here reduces. How much will be the intensity? That is the question now. So you once again should take I is equal to I naught by 2 cos square theta. What is the angle that has been mentioned in between these two? That means it is fixed. The other one is being rotated. By what angle it has been rotated? Given 45 degrees. So you can take I naught by 2 cos square 45. Cos square 45 again is half. So ultimately it becomes I naught by 4. If I naught is the original intensity, is it not 1/4 of the original intensity, please? 1/4 means, can't you just say this one 25% of I naught now? What is this 25%? You can definitely understand, because it is becoming 1/4. 1/4 means 3/4 of the total intensity of light has been filtered over here. Only 1/4 that is coming out of that. That in the sense you can understand that in terms of percentage, when this fellow is asking you, it comes to be 25%. But one thing you should understand, in such models, technically they used to ask you a question in a different manner sometimes. What is the technique over there? Problem will be the same. It will be rotated as it is. Everything will be same. But what that fellow says is, fraction of intensity of light that is filtered by the analyzer. It is transmitted, he is talking about. When analyzer is being rotated by 45 degrees, how much energy that has been transmitted, he is asking in this question. Therefore, it will be 25%. Sometimes that fellow may ask you, how much has been filtered? Filtered means you can definitely understand 25% is coming out, means 75% of light has been filtered over there. So the same thing in fact is happening, as I said in the beginning, cooling glass specs, when we consider 50% of light as a minimum that is going to be filtered in that case, please. Of course, depending on the number of Polaroids we people are using and whatever the angle that we people are making in between them and all, you can even reduce that value to 25% or even below this one also. So in all these cases, this is the only formula which is going to be useful for you to calculate either the intensity of outcome or the output, whatever we people are getting in the form of polarized light, or we people can take up even the corresponding amplitudes here. Theoretically, one more point I just want to mention in the final stages of this topic. That is, when we discuss about polarization, the important most theoretical concepts are in the case of double refraction. In the case of double refraction, we will be finding ordinary image and extraordinary image. Ordinary ray is going to form ordinary image. Extraordinary rays are going to form extraordinary image. The point you should understand, when the crystal is being rotated by any chance, ordinary image lies there only. It will not move. Whereas extraordinary image rotates along with the crystal as such. And another thing you have to remember theoretically is, ordinary image formed over there obeys every law of optics, including Snell's law. Whereas extraordinary image, when we consider, that does not obey any of these laws of optics, particularly Snell's law. Means what? Its refractive index is not constant. Velocity of light is not constant. For which ray? Extraordinary rays refractive index varies from direction to direction. Velocity of light varies from direction to direction. Automatically we can even understand wavelength also is a variable like. So these are the areas what one has to remember as far as this topic polarization that is concerned. In the final Eamcet examination, you will be getting one question surely from this particular chapter rather, and many a number of times in the past that fellow has asked either the problem from Young's double slit experiment, that is interference, or the application of polarization as such. Polarization particularly, problem means Polaroids only they will ask you, otherwise theoretical means any question theoretically of polarization can be asked there. So try to work out well the very few number of formulae we have of this chapter. It is easy to remember and rather do the problems based on this one also. So all the best as far as this particular chapter is concerned for the forthcoming Eamcet examination for all of you. Good luck to all of you. Thank you.